Hey kids, it's Dr. Rones here with your lesson on point-slope form of an equation. This is another way to accomplish something that we've already done. Some people find that redundant or frustrating. I find it empowering to know that you can do what you have learned in a variety of ways. And so this is another one of those lessons where we'll re-engage what we've already learned and we'll learn something a little bit different. That again accomplishes the same thing, and then you can make your decision in the end which one you prefer. So again, this is not going to be a perfect lesson. I do my best. Other teachers might teach this a different way. I'm just trying to provide some support for my students at home. So that's my little disclaimer I like to put in each of these videos. So here you will see the equation that we use for point-slope form. Y minus y1 equals m, and then times the quantity of x minus x1. For this, you will be substituting values in for y1, x1, and m. But the regular y and the regular x without a subscript do not have values that get substituted in for them. That is something that really confuses students. So you'll never sub anything in for this y and for this x when you do this. Now let's see how we have been able to previously get around the use of point-slope form. So let's say, for example, we have to write an equation of line that has a slope of 4 and goes through this point. And remember that a point is made up of an x and a y value. So previously, we would use this information in slope-intercept form to find the intercept and then write an equation. You may recall, so the y is 2 equals m is 4, x is 12 plus b. Is this familiar to you? 2 is 48 plus b. Solve for b. So b is negative 46. And from that, we can derive the equation y equals 4x, because our slope was 4, minus 46, which is the intercept that we calculated using slope-intercept form. Now, if you like that way, because that's the way you learned, then you go for it. But I do want to show you another way that you can find this, because perhaps you will like it a little bit better. So we're going to use the same information that was given to us using point slope. So remember, y is always going to be y minus y1. There's only one point here, so there's not a y1, y2. It's just this one. So y1 is 2 equals, slope is 4 times x minus 12. Now, you guys know that I'm a big stickler about writing values that you substitute in parentheses and how that's a good habit to get into. This is one of those small places where it's kind of frustrating to use all those parentheses and maybe even confusing. So this would be an okay place to drop all those parentheses if you would prefer to write your equation like that, because it is a little much to do all those parentheses. Okay, let's use some distributive property. 4 times x is 4x. 4 times negative 12 is negative 48. Y minus 2 equals. And then we want this to be in slope-intercept form, so y equals, nope, that's y plus 2. The reverse of, y minus 2, the reverse of positive 2 is a negative. I'm talking backwards. I shouldn't think about math while I'm talking. This says y minus 2. The reverse of a negative 2 is a positive 2. That's what I was trying to say. Sorry, guys. Remember that thing I said about this not being the perfect lesson? You know what I mean. Y equals 4x minus 46. So we get the same exact thing. It's a little bit faster, some people say, but again, you pick whichever one you like. It doesn't matter which one you use, so no, it doesn't matter. And which method do you like best? Maybe you can practice both of them in this lesson and determine which one you like best. So let's do several practice ones before I set you off on your homework, because this could be kind of difficult. Now, for a couple things to tell you before we get started on this. First of all, because this is the point slope lesson, I'm going to use point slope in these equations because I've already taught you the other strategy. The other thing is I'm just going to talk these examples through. I'm going to rely on my listeners to stop and rewatch and pause and try on their own and go back to the video at their own pace. So please don't feel like you have to write and listen and think at the rate that I'm talking, because I'm expecting you to pause and think on your own. In a regular lesson, of course, we'd be pausing and talking about this as we go. So that said, you should perhaps pause and try a couple of these on your own. I know you've just learned this and you've only seen it once, but maybe see what you can do independently, and you can push go again. Okay, so the equation again that we're using is y minus y1 equals mx minus x1. I just like to write that down so that I can practice memorizing, and so I'm lining things up right. So this is x and y. Technically they'd be x1 and y1. So y minus, where do you think kids are going to go wrong here? Y minus a negative 1. Don't forget both of them. So this negative comes from here. This negative comes from there. Hopefully that makes sense. Okay, and then equals m is 3 x minus 2. I hope you can connect where all those numbers came from. So y1 was here, x1 is there. So y plus 1 is 3x minus 6. Y equals, nope, it's y plus 1. So the reverse of positive 1 is a negative 1. What I do on one side, I do to the other. Y is 3x minus 7. And so if you use the slope-intercept form to find the intercept and then plug it in, you would have gotten the same result. So again, I just want to remind you, feel free to pause and attempt the next one, see what you can do on your own, and play away. So we have this time an intercept that is a fraction. We can handle it. So y minus 4 equals 1/3. X is going to stay the same, minus x1 is 3. Remember, this y and x always stays the same. Y minus 4 is 1/3 of an x. 1/3 of negative 3 is negative 1. Put this in slope-intercept form by adding the 4 to get y is 1/3 of x plus 3. So this is going to be, this isn't part of the lesson, but I just like to do this occasionally. So see if you can envision this on a coordinate plane. I'd have a positive intercept. It's going to have a very gradual slope. It's positive, so it'd look kind of like that-ish. Just for fun. Okay. Now we aren't given the slope. We have to calculate what our slope is first. And before I tell you, I would like for you to please take a moment and see if you can do this independently. And remember, we can calculate the slope. M is y2 minus y1 over x2 minus x1. Or in this case, it would be negative 7 minus a negative 5, those become positive, over x2 minus 4. If you come up with inaccurate numbers, I recommend that you label this up so you put in the correct things. And so negative 7 and 5 is negative 2. Negative 2 minus 4 is negative 6. Negative over a negative is a positive. 2 6s 1/3. So I just squeeze that in there. So here I have a slope of 1/3. So go back to our new equation. Y minus y1 equals x minus x1. Now we have our slope in y1 and y2. We can, oops, this should be an y1, sorry. Now we have an x1 and a y1 that we can use. And so we can just disregard this other point. So y minus y1 is negative 5 equals 1/3 x minus 4. And so distributive property gives us 1/3 of an x minus, oh no, what do we do? We're going to get a ugly fraction. I don't know why I wrote parentheses there. And subtract 5 and subtract 5. Y equals 1/3 of x minus, that's 1 and 1/3, and 5 is 6 and 1/3. Whew, we don't do a lot of fractions. Are we afraid of them? No. Can you handle them? Yes. Would this be a nightmare to graph? Absolutely. I'm not going to make you graph that one. Okay. Take a second, make sure you get it written down, make sure you understand, walk through that again, and then again, I recommend that you pause this and try the last one before you watch. Okay, here we go. x1, y1, x2, y2. So remember, slope is y2 minus y1 over x2 minus x1. So in this case, it would be negative 3 minus 7 over negative 4 minus a negative 9. So negative 4 plus 9. Negative 3 minus 7 is negative 10 over negative 4 plus 9 is positive 5. So negative 2 is our slope. And so y minus y1 equals mx minus x1. Or y minus 7 equals negative 2x minus a negative 9. Okay. Distributive property. There. And write it in slope-intercept form. So it must be y equals. So now we have negative 2x minus 11. Now remember, you could have done this ages ago using slope-intercept form, but this is another way that you can find the same results, and knowing all of these different strategies is good for you to build number sense and helps you to be flexible and think about all the things that we're doing and to see their interconnectedness. So it is not meant to frustrate you. This is one of those that I get a hard time from kids. About it being repetitive, but that's okay. A little repetition never killed anyone. Okay, so here we go with this. For this next first section, you're going to find the slope of a line through given points. This is review. Again, a little review never hurt anybody. Here you're going to write an equation in slope-intercept form. I mean, you can use the 2 points if you want, but I think you could easily count your slope, and they all have a very clear intercept that you don't necessarily need to calculate. If you want to do it mathematically, you can, but I feel the work smarter, not harder motto fits there. Okay, for 10 through 18, you are going to write your equation again in slope-intercept form. And I would like for you to please use the point slope form when you're doing your work. So of course you'll have lined paper when you're doing this. This would be a lot to do in your head. And again, I want you to use point slope, the new strategy. The next section is pretty much the same exact instructions. Write an equation in slope-intercept form of a line that passes through the given points. It doesn't give you the slope. You will have to find your own slope. And for this part, if you prefer to use the slope-intercept form of finding the intercept and writing the line, you can there. But I double dog dare you to keep using point slope since that's this lesson. But part of the beauty of knowing multiple strategies is being able to choose your own once you're familiar with both of them. And let's see, let me get you started on this first word problem, and then we are going to do the next one in class. So this is about classified ads. This is really old. You kids don't even know what classified ads are. Newspaper used to come with itty bitty teeny tiny font on one big page, and people would be advertising all kinds of things, usually cars, and you could find jobs that way too. But anyway, so you'd have to take out an ad to do any advertising. So anyway, it costs $2 a day to place a one-line ad in the classifieds plus a flat service fee. So 1 day costs $3 and 4 days costs $9. And so you could say 1 day costs $3 and 4 days costs $9. So you can write a linear equation that gives the cost in dollars, y, in terms of the number of days the ad appears. And that's the x. And then you'll use that equation to find how much a 6-day ad would cost. Now, could you go ahead and find out what the fee is and multiply 6 and 12 and figure the fee and go from there? Yes, you absolutely could. But that would be not using this cool strategy that you just learned. So I would like for you to try that using point slope form. So anyway, again, we're going to do this in class. If you need more help than all of that, that's fine. People learn things at different rates. Some people need a little bit more, and that's fine. That's where my job comes in. And so there's my email address. Please don't hesitate to get a hold of me. Anything I can do would be fine for me. So thanks, guys. See you in class. Bye.